Am I audible? Привет, guys. My name is Pawel Rzepa, and I came to you from Poland, from Wrocław. And today I want to speak more about fuzzing and to present you a world of fuzzing, encourage you to start fuzzing. I call this underestimated method because whenever I'm speaking with any developers or testers, they usually don't know what the term fuzzing really means. So let's start from a little survey. Who from the audience knows what the fuzzing is? Please raise your hand. Okay. So hope that after this presentation you will know how to start and you will be encouraged enough to start. What are we going to say? Some general stuff. Let's start from definition. How everything starts from the history perspective. We will start then from the mutation-based fuzzing, so-called dump fuzzers. Very easy to start. We will create some APK bombs on Android device. Then we will go to much more complicated stuff. Instrumented fuzzing. We will not go very deep into the details of algorithms implemented in this, but I want to show you the idea. And then we will go to the generation-based fuzzers. There are the fuzzing frameworks. We will create some definition to fuzz the FTP server. And in the end, I would like to encourage you to add fuzzing to the software development lifecycle. Before we start, I would like to present myself. I work as a contractor for SoftServe. Is it visible? Yes. Okay. On my daily basis, I'm developing advanced fuzzing module to the CyberFloat device. This is the device. It was presented on this year's edition of Black Hat in Las Vegas. Spirent is an American company. They are selling CyberFloat for the manufacturers of network devices, and you can fuzz the other devices or generate some distributed denial of service attacks. So it has potential because there's not many competitors on this market. I'm also an OWASP member, as Nazar told you. We are arranging not so big meetups, not so cool as here, but hope that it will be in future. Okay, let's start from the definition. The definition I took from the book called Fuzzing Brute Force Vulnerability Discovery, and I encourage you to read this book because it is covering really whole topic of fuzzing. And generally say, to make things simple, fuzzing is a method of discovering faults in software by providing invalid input. Of course, and monitoring if there are any exceptions, any anomalies are happening. To make it more understandable to all of you, I've created a little cartoon, and fuzzing is like a child who doesn't understand any rules, who doesn't know any instructions. The child is just grabbing an electronic device and just play with it. By pressing random buttons, by doing some random actions. Sometimes they can crash a device. And we old people are calling it that they crash the phone, but actually they prove that this electronic device is not robust to the random input. So how it all started? Everything started on the University of Wisconsin when in 1988 Professor Martin Miller He was using an internet during the storm with lightning bolts, and 1988 was that time when to internet you had to have the modem, and the lightning bolts were creating an interferences into the cable, so the signal wasn't as clear as normal, and so such interferences created an invalid input to the programs, and those invalid inputs created crashes into the program. So the professor Martin Miller thought that it's an interesting stuff, so he asked his student to create such fuzzer and see if it really makes sense in the world of testing software. Such the very basic fuzzer can look like this. So we created an infinite loop, and as an input to the tested program we are giving a virtual generator of random stuff. However, the question to you, do you think it is effective, such thing, even if we crash the application? We all agree that no, but why not?
Because you hang.
No.
It's unlocking random.
You know what exactly crashed?
No.
Yes?
We should have a seed, a random seed, to reproduce this crash.
Okay.
But
But
you hang because
random generates an unlimited stream of numbers. Like we should have cut it at some point. Yeah, it's wrong. There's a bug.
all right.
Already.
Yeah, but okay. But yeah, the idea is that it is really we don't monitor any input, so we don't know what really crashed our program. What is more, we don't monitor an application. Of course, we can see it in front of monitor and stare at the monitor to see if anything is happening with our program. But sometimes we got a crash and there is no pop-up message that any error happened. Just the application hangs and nothing more happened. And generally, in most cases, such random input will be ignored by the application because the application is expecting some fixed input, and everything what is not starting from some fixed, like the metadata of PDF file, and the Adobe Reader will not accept the other types of files. So this brings us to the mutation-based fuzzers, and generally the process of mutation-based fuzzers look like on the slide. So we have some sample data, some valid sample data. Let's imagine that we are testing the Adobe Reader or any reader, and we have a valid sample data that is a valid PDF file. Then we are mutating it via one's mutation algorithm. It can be like bit flipping, so the random bits will be flipped. So ones became 0 and the zeros became 1. Byte flipping to flip whole bytes, or chunks like cutting one portion of data and putting it in different places of the data structure. Then such fuzz data we are giving to the input of the program and observing if any crash happened. So in practice it can look like this. Here I'm using the fuzzer Radanza. It is the open source fuzzer, and it generally is very easy to use. So I've created a sample data, a simple txt file with the string inside of it. Then I created 5 fast samples based on this sample data, and you can see how it works. In the first sample, there is added some invalid character at the end of it. In the last, the valid fragment of string is copied lots of times, and so on and so on. So, can we do anything with such information? To prove it that it is possible, I would like to present you the APK bombs. A lot of Android antiviruses are verified if how effective they are in finding malware on your phone, but there are very little of researches about how those antiviruses are really secure. So very often those software, those antiviruses can be then opened to your phone. And the APK bombs are fast APK files. APK files are the Android applications. It is the extension like executable in Windows systems. And if you will give such APK bomb to the input of Android antivirus, very often this antivirus reacts very differently. And as an example, I would like to present you a winner, the best Android antivirus in July 2016, based on the avtest.org. Whatever, it is just one of the first entries from Google. Yeah, you see the list of the best. I've never heard about it before, but yeah, this is it. This AHM Lab Mobile Security. And here is how I made this experiment. I created 3,000 of fast samples. This application that I put as a sample, ComApps Appius APK, is actually the very little application which is testing application. It generally do nothing. It has just one action, but it is very little. And then I fuzz it and move it to the SD card. So there is the tool called ADB. If you ever played with Android, this is because my tests were firstly made on the emulator, so I moved this to the SD card. If anyone is thinking what is SD card, this little thing is SD card. And of course, I've plugged the log cuts to somehow monitor which process on my device really changed the state. And it looked like this on these screens. So it wasn't by default to check files on the SD card, but if you check it, then the scan happened, and after all, we had the first crash. So I thought, whoa, is it too easy? So I grab a tablet and try the same thing. So in tablet, it was quite different reaction, because after putting all this stuff, inserting my micro SD card, I ran it, and generally, from the security point of view, the worst thing happened, because it just black screen, but there is no information to user. So the user still believes that he is protected by these antiviruses. But no matter now I pull out this SD card, the application stop working. So now imagine the situation when the victim just went out to the toilet, and you can just put the SD card with these APK bombs, And now you can easily put malware on his phone. Of course, via the different path, but it is not important here. So, now, what are the limitations of such attitude? Because, of course, it was easy, it was trivial, but what about the code coverage? Most of such blind attitudes, blind samples will end on such trivial if-else statements. So let's imagine there is a very rare condition, and most test cases, if not all of them, will be never touched in such blind attitude. And to prove it, I've created again the same experiment against the TCP dump in version 4.6.2. The latest one version is 4.7.4. However, Ubuntu in version 14.04 have the TCP dump in 4.5.1. So it is quite still application which is on the use. So I created again 3,000 samples and I made an infinite. It is of course ended, and all those 3,000 of samples were given to the input of TCP dump, and then the output given by TCP dump I collected in file. As you can see, I was looking from the word called segmentation. Segmentation is because of when the program ended with the segmentation fault, so the access violation in memory, you will have the output of segmentation fault. Here, you don't have it. So by such blind attitude, I was unable to crash TCP dump. Now, does it mean that TCP dump is not vulnerable? No. And this brings us to the instrumented fuzzing. Instrumented fuzzing is the white box attitude to fuzz testing. So you need to have the source code of your application and special and dedicated compiler. This compiler will detect all possible code paths and will generate such samples to cover all those paths. And of course, it is much more effective. To visualize it, if you ever played with IDA Pro, each function is one block. And blind attitude to fuzzing will end on the first line of those blocks. The rest of blocks will never be touched by such blind testing. However, if we compile the application with such dedicated compilers, then we can touch every block of code. And a representative of such instrumented fuzzing is American Fuzzy Law. It is a great fuzzer. The community around this fuzzer is working very actively now. There are a lot of plugins made based on this AFL. For example, there is PyAFL, a module to the Python. So you can use it with Python. You can create your own fuzzers for your own dedicated needs. And to use this AFL, you need to just give this dedicated compiler as the default one. And you need to, using this, you need to compile the tested application. Another thing you need to do is to prepare a valid sample. So again, if you are testing the Adobe Reader, you need to have the valid PDF file. If you are testing the TCP dump, you have to have a as a valid sample, you need to have a valid pickup file, but very little one. And the creator of this AFL fuzzer, he made a research that the most effective, his fuzzer is the most effective if the sample is less than 100 kilobytes. Funny thing about this fuzzer is that if you are fuzzing some XML parser and if you give a valid, just a letter A in the XML file as an input, after 1 day of working, you have almost valid files with whole structures of XML. So the fuzzer, every iteration it's making, he's touching another blocks of functions. You have to also create the folders for input, where you store your sample file, output, where all crashes are stored, and optionally garbage if you are curious about what samples, what fast samples were used in this test.
Oh, sorry, can you please repeat the sentence about fuzzing XML parser? I didn't catch your thought. The sentence about XML parser you mentioned just before.
Yeah. So
Can you really explain this again?
yeah. So because the instrumented fuzzing to touch every block of function, he is preparing the sample to be valid to touch this block of instructions. So if you put a letter A or any letter, anything, very, very little sample at the beginning, after 1 day of working of this AFL fuzzer, you will have in the garbage folder. In the garbage folder you will have files, XML files with very complicated XML functionalities. So the fuzzer is creating such samples to touch every functionality of this particular parser. In practice, it looks like this. It is not only the AFL GCC or AFL CLang. By the way, those two are the compilers, if you are not familiar. But you have also things like AFL Analyze to analyze your crashes, or AFL Plot to even plug into the GNU plot to make charts from the performance of your testing. There's also the folder of test cases where are ready to use samples, a folder with samples for different programs like for example pickup, which we use. As you can see on this slide, I also created the samples and run it. As you can see, it's AFL fuzz. By the parameter I, you are inserting the path to your input sample. O is of course output, and then you are using the tested program with parameters, and those two characters, two signs, is interpreted by the IFL to put a sample file in this particular place. So N and R are the parameters of TCP dump. So you can, run any program with any arguments, and you are just telling the IFL to put the sample in these two add characters. Then you can see such console of the performance of your fuzzing. And you can see that I was testing the same software, the same TCP dump, the same version, and after 2 minutes, I got the first unique crash. Now, the question is, what is the unique crash? If you are, for example, following this blind attitude and you have a lot of crashes, that doesn't mean that there are so many bugs in your software. It can mean that all those samples are stopped on the same functionality, on the same function. So actually all those crashes are one crash, one unique crash. And the AFL fuzzer is intelligent enough to know to recognize it as a unique crash. We find it, and to prove it, we can see that at the top, as you can see, at the top, strange name is a way how AFL is saving those crashes. So I call it to just crash file, and then in the GDP I ran TCP dump, giving as an input this file, and we got a segmentation fault. If I don't run it on the GDP debugger, it will only give it as an output the segmentation fault. Now, what about the remote servers? So let's assume we have a server, we want to test it. Now, what we can do? It's again, why it shouldn't work?
Why it shouldn't work?
Yeah, because let's assume you are testing the FTP server, and why this one-liner will not crash your server.
Because you're not sure that all changes which are in the middle in the server are also not, for example, catch this error.
Yeah. So during the when the input is transported via the network, there is in packets there is something called checksums, and if this checksum is not counted properly on the receiver side, the whole packet will be ignored. Also, what is more, this will be ignored because FTP is using some fixed structure. So, for example, first is the comment, and then there is attribute to this comment. So, for example, user space anonymous, and if it doesn't recognize the first comment, it will ignore it. And these are the limitations. So here I was fuzzing the distance vector multicast routing protocol, and I created here incorrectly the structure of DVMRP protocol. So, for example, DVMRP requires, let's say, the first 8 bits are the version of the protocol. Another is the length of whole packet, and so on and so on. If you create incorrectly this structure, then it will be recognized. Wireshark is of course only parser, but Wireshark cannot understand it, and the receiver, like the router, also will drop the packet. Another limitation is fix-ups. So mentioned checksums, length, and so on, like the encoding things. If they are not compliant, whole packet is dropped. Relations. When I was testing the extensible authentication protocol, there is such procedure that firstly an authenticator sends an ID. This ID should be this ID field should be the random value, and this random value needs to be then put in the response. And if the IDs are not equal, are not the same, whole communication is dropped. And regarding states, here you you can see the FTP server, and I'm trying to send the command make dir or list without being authenticated at first. So if you are not authenticated, you are not allowed, according to the FTP definition, you are not allowed to use those commands. After you are authenticated, you can have different outputs. So here we will create a definition using the pitch fuzzer. Pitch fuzzer is there is a community version, so anyone can download it and play with it. If you prefer writing in Python, then Sule is your choice. These are the fuzzing frameworks, meaning that you have to create from the scratch the whole definition of the structure you are fuzzing. So, for example, if you are fuzzing FTP protocol, you need to define each field. Like here, the FTP is a text-based protocol, so you need to create a string, and each field of the string will be fuzzed by the pitch fuzzer. If you, for example, fuzzing the PDF files, PDF consumer, then you have to create a structure of PDF files, so the fuzzer knows exactly when what are the specific fields of this structure. Then, when you create a data models, then it is time for creating states. So, as you can see, firstly, I'm authenticating myself as an anonymous, and then I'm changing a state into the state makedir to use the command makedir. And the last thing is to plug a monitor, so something that will monitor your fast program and observe what is happening, will capture all crashes, and everything you are putting to the test. Here I'm using the TCP publisher, but in pitch you are not limited only to TCP. There are a lot of other protocols which, for example, are never used IP addresses, and all of them are supported. The documentation about the pitch fuzzer is not perfect, but it is enough to start. Also, if you want to play and have some difficulties, please let me know, because I'm playing with this tool a lot. Now, time for, after creating this for a long time, it's time to run our fuzzer. So I was running it on Ubuntu. This is why I'm using Mono. And in an input, it is required only the XML file. In the second picture, you can see on the left side, you can see how the pitch is fuzzing particular fields, and on the right side, there is a console from the FTP server, and you can see how those files were received by this FTP server. So, for example, there's added some invalid string values to user comment. Then the comment pass is copied a lot of times, and so on and so on, until after 8 iterations, I go to first crash, and in fact the pitch fuzzer is doing the job for you. So the log output from the Linux crash handler is saved in a file, so you have ready proof of concept that it really made a crash. So now, again, we are talking about those crashes, but not always you will get a crash. Sometimes you will get a crash that this application will stop working. Sometimes it will be still working, but the crash really happened. And your monitor programs will really capture this, but you as a just observer of it, you will not see it. So every crash can be treated as a pure DOS attack. However, in for example, terms of TCP dump, the denial of service is not something that really can be profitable. Unfortunately, not every crash can be exploited, and to analyze if this crash can be exploited, if we can go farther from this crash to write our own exploit, it requires further analysis. And depending on the operating system, you can analyze those crashes differently. For example, on Windows, we have the bank exploitable. It is the plugin to the Win debugger, and when you run your program with sample, which is doing the crash, then you are running this bank exploitable, and as I will show you in the example, it will categorizing a crash if it is exploitable or maybe exploitable. It will do it for you. On Linux, the CERT made very similar stuff, but working on the Linux architecture, the GDB exploitable plugin, and on OS X you have the Apple Crash Wrangler monitor. Here is the example of bank exploitable. So this is the screenshot from Win debugger, and this particular crash were classified as exploitable. Now, let's do this. Let's do process from fuzzing. If you will take a look on this classic waterfall of software development lifecycle, I would say that fuzzing is begin on the coding phase. So each developer, after creating a functionality, should test it by fuzzer. You can write your own wrapper to move the fuzzing input to input of your function. Then, of course, testers should know how to fuzz and should start the fuzz testing, whole scenarios, depending on the technology you use. And then you should have the procedures, you should be ready that if you release your application, then you have to be ready that some software security researchers will find the bug and will report it to you. So then you have to have the procedures that, okay, I have the resources that are taking this report from this security researcher and see if it is true that this particular error is really bug, or is it really something exploitable, something you should care. To summarize, fuzzing, just to remember the most important things. Fuzzing is a way of testing by providing invalid input to your software. A good fuzzer should contain not only the input generator, but also history of generated input, so you can see what was used, what caused the crash, and a process monitor that will observe your application if it is really causing any changes of state in your applications. Main type of fuzzers are mutation-based, so you have to give a valid sample, and this sample will be then mutated. And generation-based, when you are starting from scratch, so you have to write whole structure, And generally, for example, the company, the creators of Pitch Fuzzer, they started their business by doing this fuzzing framework, and now they are making money on creating such definitions of different protocols, and they are simply selling those definitions. So, for example, if you want to test FTP protocol, you have to buy from them a ready-to-work definition that you will just run from command line. And fuzzing should be a part of software development lifecycle. Are there any questions?
Yeah. One question: what kind of issues does it find in languages with managed memory, like Java, for example?
Mm-hmm.
What kind of issues does it find? Like in C, yeah, it's understandable. Like.
That's true. To be honest, I've never tested the Java software. However, you can still see how you are handling exceptions. Yeah. Are there any other questions?
Yeah, so how to, which of Pitch Fuzzer, American Fuzzy 2, which one is the best one for distributed fuzzing?
There is no simple answer to this because it depends. For example, it depends on what you want to use it against. For example, guys from the Project Zero, the Project Zero Security is the Google group of security specialists. They are using their own fuzzers. Why? Because they are fuzzing their software on thousands of virtual machines. So they care about the performance. From the performance perspective, Pitch Fuzzer is not the best. So it really depends on the usage you want to try. Any other questions? If you have any questions, if you think that I didn't hit some important for you stuff, then please write me an email. I will be glad to help you. Thank you very much.